calculator. These are the only equations you need. You just need to know if they're positive or negative. It's this one, but it's going to be negative because that square root of 3 over 2 is negative, so it's negative 0.57. How about pi? Good, because 0 divided by negative 1 is 0. And then let's see, 7 pi over 6. Negative divided by a negative is a positive to right there. The next one, 1. Oops, right here. Nope, right there. Four pi over 3. $1.7, is that what it was? And then how about 3 pi over 2? Nothing. What is that called again?
Vertical asymptote.
An asymptote. A vertical asymptote. You're right. By the way, most asymptotes are vertical.
That makes sense, because why?
Because otherwise it would be a relation back on itself. All right, now what it looks like, and this is hard to draw, so watch me first. Goes like this, and then it changes concavity. Concavity. Khan Academy. Concavity. Do you know what concavity means?
It's
Right.
the direction.
Concave. Everybody look at my hand. Everybody make your hand like mine. That's concave down, like you're throwing it on the ground. Okay, concave down. Concave up, like a cup. So this is concave up, concave down, concave up, concave down. This part is concave down, and then it changes concavity to be concave up right there. All right, then what happens at 5 pi over 3? Is that 5 pi over 3? Yeah, 5 pi over 3.
To the bottom again.
Jump into the bottom again, because this time it's 1 negative, 1 positive. So what, negative 1.7? And then negative 1. And then, what was it, 0.57? And 2 pi is at 0. And then here, it's also at 0.57. Now we're back into that first quadrant. We're just walking around the circle again. Nine pi over 4 is 1. 7 pi over 3 is 1.7. And 5 pi over 2. Asymptote. Or as Carly says, no. And then draw in your concavity. Also, make sure that you draw it in over here. That negative pi over 6 was a little short of negative 0.6, so it should look like this. And that's what the whole shebang looks like for tangent graphs. All right. So let's start with domain on the right. Remember, we want this to be correct. This is something we're taking to college, or you are. I've already been to college. I did it. I'm sure I'll go back for fun and more pay later.
Oh yeah, how far have you gone after Calc 3?
After Calc 3,
Yeah.
I did a advanced calculus after that, and then no more.
Oh.
So I went to UW-Madison, and when you're in the math teaching program at UW-Madison, they give you 2 paths that you can go on as a math teacher. I took 16 math classes in college. And you can either specialize in calculus or specialize in statistics. And I specialized in statistics because I enjoy statistics, and calculus I did not enjoy when it got to multivariable calculus. But I was good at it. I just didn't really like it. But I really liked statistics, so. Anyway, domain. How far does this graph go left to right?
Negative.
Kind of. There are some things that don't happen, though. It definitely goes left and right forever. Like these things are going to keep going, right? Left and right forever. But there are some points where it just doesn't exist. Which is where? The asymptotes. In fact, that's how we're going to write it. We're going to say it is a negative infinity to infinity except the asymptotes.
How do you write except asymptotes as a...
If it was mathematically, you would say except pi over 2k, meaning that any multiples of pi over 2. No, that's not true, because it's not multiples of pi over 2. Pi over 2 plus pi k. And then with any, like, if it was 0, then it would be pi over 2, which is where the first asymptote is. If it was 1, then it would be 1/2 plus 1, which is 1.5, which is where the second asymptote is, etc.
So it doesn't matter what variable it is, it doesn't have to be k.
It doesn't matter what variable it is, but it is often used as k anytime they're talking about repetitive things like that.